Okay, this is Advanced Math 2.5 Notes, Part 2. Remember there was that last one I did not get to, and I want to go ahead and finish that one off now because it's definitely on the test and it's something you do need to understand. So I want to take the time to do that now. Where we left off on the last lesson was number 4, and we talked about isolating the radicals, but there were too many. There was, for example, something like this. There's only one radical, so you just move the 3 over by dividing. There's only one radical, so you go straight to squaring both sides. When you have something like this and you subtract over and there's multiple radicals, you isolate the larger one. So we moved over the smaller one, squared both sides, double distribution, combined like terms, noticed, oh no, there's still a radical, so we now have to go back to step 1 and isolate this, subtract, divide, square both sides, and we end up with 4. And we even checked it, and it indeed worked. Okay, so we're going to move on now to number 5, which is the square root of 2x minus 3 minus the square root of x plus 2 equals 1. Now when you have two radicals like this and they are both the same size, it does not matter which one you move over. I'm going to move this one over because it has a minus sign there and it's easier to just simply add it to the other side. So I'm going to add the square root of x plus 2 to the other side. It cancels out there, leaving me with the square root of 2x minus 3 equals 1 plus the square root of x plus 2. And I cannot combine these because they're not like terms, so I write it as 1 plus the square root of x plus 2, leaving this square root on this side. Okay, we're ready to square both sides. And when you square both sides, on this side, again, I've said square roots and squares are inverses of each other, so they undo each other, leaving you with 2x minus 3. As tempting as it is to square one squared and then the radical undoes they undo each other, it doesn't work that way. You have to use double distribution. All right, and using double distribution, we are going to multiply 1 times 1 is 1. As the square root of x plus 2 is 1 square root x plus 2. Then I do square root of x plus 2 times 1, which is another 1 square root of x plus 2. And on our last multiplication piece here, you're multiplying these same bases and they both have radicals, so the radicals undo each other, and it's simply x plus 2. Now if you notice, I still have a radical here, so I'm going to have to isolate that. I'm first going to combine like terms, so it's a little easier on the eyes. I have a positive 1 and a positive 2. I'm going to pull it out to the front. 2 plus square root x plus 2, square root x plus 2 is 2 square root x plus 2 plus the x at the end. Okay. Sorry guys, you're like, what is she doing? That should be a 3. 1 plus 2 is 3, just going too fast. I am going to continue. I want to isolate the radical, and by doing that I'm going to subtract the 3 and subtract the x. Subtract the 3 and subtract the x. Now why am I doing this? Because I'm trying to isolate this radical. We're going back to step 1. 2x minus x is 1x, negative 3 minus 3 is negative 6, equals 2 square root x plus 2. Now I want to talk a little bit about isolating. To isolate, we should divide the 2. Divide the 2 over to the other side so that the square root's by itself. Personally, I don't like doing that because dividing, I'm going to erase this, so don't write it down. Dividing by 2 does isolate, but that leaves me with the fraction over here. And then when I square both sides, it's going to not look so nice. So if the 2 does not divide in evenly, or the 3, or whatever the coefficient may be, I don't divide it. So I'm going to leave it here. For example, if this was 2x minus 6, let's just pretend, I could divide the 2 and it reduce evenly into both of them. X minus 6, the 2 does not reduce, so I'm not going to divide it. I'm going to leave it where it's at. And here's how it works. I'm going to square. I'm going to square. I know the left side is not distributing. I have to double distribute or FOIL. I can't distribute the exponent. Now here, this piece and the square do undo each other to be x plus 2. But this 2 out here is not inside the radical, so you have to square it. So 2 squared is 4. And I put parentheses around the x plus 2 to remember to distribute the 4. Now why am I allowed to distribute this exponent and not this one? Because 2 and the square root of x plus 2 is held together with multiplication, so I'm allowed to distribute. The x and the 6 is held together with the subtraction. I'm not allowed to distribute. FOIL, distribute, and be done. So 4 times x plus 2 is 4x plus 8. And this is x squared minus 12x plus 36. And now we're done with step 1, which was isolate the radical. We've already undone the radical. Now we're ready to solve. So I'm going to subtract the 4x. I'm going to subtract the 8. And we're going to get ready to factor and solve using the zero product property. X squared minus 16x minus, again, going too fast, and you guys are wondering what the heck is Mrs. Torres doing. That should be a positive. X squared minus 12x plus 36. And so 36 take away 8 is 28 equals 0. All right, so some of you, I'm sure if you were doing it on your own, you wrote that as a positive 36, not a negative. X squared minus 12x plus 36, subtract the 8, 36 take away 8 is 28. And then we double bubble and solve. So go ahead and factor. You can hit pause if you'd like. X and x minus 14 and minus 2. X equals 14 and positive 2. And then you check. Okay, now when you check, you plug it back into the original before there was any work done. Square root of 14 times 2 is 28, take away 3, minus the square root of 14 plus 2 is 16, equals 1. Okay, 28 take away 3 is 25, square root of 25 is 5, square root of 16 is 4, and 5 minus 4 is indeed 1, and all is good. Okay, now we're going to check the 2 into the original. 2 times 2 is 4, 4 minus 3, minus the square root of 2 plus 2 is 4, 4 minus 3 is 1, take away square root of 4 is 2, and 1 minus 2 is negative 1, which does not equal positive 1. Therefore, 2 is an extraneous solution, which means our only solution is 14. Okay, be ready for with questions tomorrow if you do have any. That's it for this lesson.